What's up guys, Shawnthebro here, and in today's episode of the Fighting Game Tutorial Series, part 246, we are going to be moving over the rest of our AI practice state tasks to the actual behavior tree and creating an individual code class for every task. This is useful because before we had it in the base AI controller, which did work and technically would be fine, but as we get into many more AI states like we're going to need for this series, it is going to become very full very quickly. So if we come into practice mode, load up our game, skip through everything here, you'll see right now the AI isn't doing anything. I don't have any state hooked up to them for practice mode. They're also not controllable by the player at the moment though, because they are still an AI controller. In today's episode, I've added more states, so the ones we previously had for practice, which are jump, crouch, and block. In the last episode, we just had jump. So we're keeping jump, and obviously I can hook jump up to this selector and cause the character to jump. But you guys know that one works. So let's skip past this one. And instead, let's make the first one crouch. So if we have crouch in here, we will be able to come into our practice mode, play up our game, skip through everything, and the AI character is crouching. Just like we would expect to happen. Now we can exit one more time and instead put the block state, or AI task, in here. Save that, play, practice, skip, and now the AI character is blocking the entire time. Again, just as we would expect. So now we have real AI not only performing one task, but we can also choose multiple tasks and actions to actually do. Of course, we're not going to want to close the game every time and change this to change our task, but we're adding all the tasks that we had previously through our AI controller into the actual behavior tree. Also, I mentioned this last time, but just a reminder, this is not a blueprint. This is a visual representation of code of a behavior tree in Unreal Engine. This is just an interface to put these states up and put them in a certain order. This is not a blueprint. So anyway, that's what we're doing for today's episode. Before we hop into the actual content for today's episode, if you want to get caught up in the series and check out how we've done everything in our game from our hitboxes, launchers, super moves, all that great stuff, you can click this link in the top right corner right here, which is the entire playlist of the Fighting Game Tutorial Series. Alternatively, if you don't care about that and you only care about AI, behavior trees, practice states, that's perfectly fine. I do recommend you watch this episode right here, which is the previous episode on AI tasking. We're going to be taking that logic today and expanding upon it, making more tasks out of that. And so what we're doing should make more sense. We're going to go through it a little bit quicker today since we already know about tasking, but we're also going to get more done. With that out of the way, we can now go ahead and get started. The first thing I want to do is add my new AI task classes. So like before, I'm going to go to wherever I want to create this class, which for me, C++ classes, fighter template. And I made an AI tasks folder just to organize this a little bit. Now, in the previous episode, I had jump, and I technically had move away from opponent. This is something that is coming very soon, but I wanted to move over the other two practice settings ones that we had before implementing a new one. So I had these two, but we're adding these two today. And here I'm going to right click and new C++ class. Then I'm going to go to all classes, BT task node for behavior tree task node. And this is the one we're going to choose as the parent, so hit next. Then you can name these whatever you want. I like to name AI tasks, AI task underscore, and then the name of it, so block or crouch. And the reason I do this is because when we are in the behavior tree and we're searching for this node, it doesn't come up like AI task anymore. It comes up as just block, just crouch, just jump, move away from opponent, all that good stuff. You can just say the name of the task you want them to perform, which I find very nice. Then go ahead and create the class. Now if you run through Visual Studio or Rider, then you are going to have hot reload and live coding pop up, and the class should be created successfully, but you may have to close the editor, and then when they are, go to the code. So I'm in my code now, and I have my source, project folder, AI tasks folder, and all my files were made correctly, specifically these 4 files for today's episode. Now let's just start at the top here and go to AI task block, but let's start in the header file of that. So AI task underscore block.h. Everything you see for the includes, the class and uClass, the generated body is all going to exist when you make this class. However, I've added everything that I have highlighted here for today's episode. So the first thing I did was add the public keyword here for the constructor and our execute task function. And this is very similar to what we did in the AI task underscore jump in the previous episode. The differences are mainly the names, right? So if we have UAI task underscore block for our class name, then our constructor has to match that class name. So UAI task underscore block. And this override comes from the UBT task node class. So this one's going to be the same regardless of the name of our class. So this one you can directly copy from AI task underscore jump if you want. But this is the logic that occurs when the task is executed or run from the behavior tree. And it's virtual EBT node result or eBehavior tree node result ::type. So it returns the result of the behavior tree, task execution, basically whether it succeeded or failed. The name is execute task. The parameters are uBehavior tree component reference or ampersand, owner comp for owner component, and uint8 pointer node memory. And we're saying this is an override, so even though the parent class has it, we want to do something specific in this class. Now we can go to AI task underscore block CPP. You'll have this include at the start and your copyright notice, so everything else I've added for today's episode. First, we can go ahead and create the constructor. We don't have anything to put inside of it right now, but it is good to have a constructor in case we ever need to use it. So UAI task underscore block, : UAI task underscore block, basic constructor. Then we have our overridden function here, EBT node result, : type, UAI task underscore block, : execute task with our parameters. And in here, we want to check if there's an owning controller, because this is a task on a behavior tree, but we need to get the owning controller, the one that's having this task executed. That way we can do anything with it. And to do this, we can use the controller type that we're expecting to use. For us, that is our base AI controller. To be able to use the base AI controller in this class, we're going to need to include it. So include base AI controller.h. Then we can get the owner component .get AI owner. That's a function call right there. This will get the owner of the behavior tree component. And then we're going to take that entire thing and put it inside of a cast. So cast a base AI controller owner comp.get AI owner, which will return an owning controller, which is a base AI controller pointer. And we wrap all that inside of an if statement, because if this is true, if the cast succeeds and we get this as a result and it's valid, then we want to go into this logic. So if it is true, we go in here. We are in the UAI task underscore block, so we just want to force the controller to block. That's what we're doing in practice mode, and that's what we're going to be doing here. So owning controller, force block. Now, since we were able to call force block, I'm considering this a success, so we call finish latent task, owner component, EBT node result : succeeded. Now that we know the task is finished with a success, we also want to return from execute task with a success. So return EBT node result : succeeded. Then I have an else statement. So else if this owning controller couldn't be resolved, or basically we couldn't grab the owning controller from the behavior tree component, then we're going to assume this is a failure because we're not able to call force block on it. So we're going to finish this task with a failure. Finish latent task, owner comp, EBT node result : failed. And we're also going to return that for the execute task function as well. So that's our basic UAI task for block. Now let's do the crouch as well. So AI task underscore crouch.h. This should look very familiar now. So everything we have here, and really all of this is going to be already present. But everything I have highlighted right now is what we have to add. So first of all is public. Then we want to add our constructor, which is UAI task underscore crouch. Then we want to override the same function we did in the block. So virtual ebt no result : type, execute task, behavior tree component reference, owner component, int8 pointer, which is node memory, and we're overriding that function. If we go to the CPP file, we have an empty constructor because we don't have to do anything with it yet. Then we have our overridden function again. This is going to be exactly the same logic, except for the function that we are calling. So we are going to make sure we include our base AI controller.h so we can get this type. And then we want to make sure we can get that type from the owner component, get AI owner, and cast it to our base AI controller. If we're able to get the base AI controller out of that, we want to call force crouch because we are in the AI task crouch class. Since we were able to call force crouch, we want to finish the latent task owner component with a result of success. Then we also want to return success from this function. Else, if we weren't able to get the controller, we want to call finish latent task with the owner comp, and we want to say that we failed. Of course, because of this, we're going to return failed as well. Now, since we have these tasks in working, we can actually go back to the base AI controller.cpp and scroll down to the tick function. In here, you'll see that I've taken out force block, force crouch, force jump, and the idle state. They're all commented out, and yet my logic was still working in the example earlier. We don't actually need this practice state enum in the tick function anymore. You could keep the practice state enum itself in the AI controller because it could be good to know what state the AI is in based on player input on the menu for practice settings. That way when the player changes it, say they change the AI behavior from jump to crouch, this AI controller has a reference to that and can call the appropriate tasks in the behavior tree. So I wouldn't remove the enum or setting the practice state in here. I think that is perfectly fine, but I am going to remove this entire switch statement on the practice state of the base AI controller, which is going to clean things up quite a bit. Now we should be able to run the editor again, at which point everything should work as expected. So anyway, guys, that's what I got for you today on AI tasks. Now, all the logic we had in the series to date on AI is updated to the behavior tree, which is the method we are using to make an actual AI that thinks and works as it should. So if you enjoyed this episode and you want to support the channel, please subscribe. It does more for myself and the channel than anything else you can do, and that is completely free. You can also support me further by joining the Patreon, YouTube membership, or Discord subscriptions. You get benefits for doing that as well. If you ran into any problems with this episode or setting up AI, feel free to reach out to me on Discord. There is a link in the description to our Discord community where myself or someone else can help you with your issue. Anyway, guys, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.